So when I get to this step and I separate it, now I need to reduce my fractions. So I'm going to do 44 over 104. And math, enter, enter, and I get 11/26. And then I'll do 64 over 104. Math, enter, enter, and I get minus 8/13 I. So there's my final answer as a complex number in A plus BI form. Let's do this last one, number 8. 4 minus 3i over 5 plus I. And I'm going to have to multiply by the complex conjugate. Remember, the first number stays the same, and it's the second number that changes. And then I'm going to FOIL the top and the bottom. First, I get 20. Outers, negative 4i. Inners, negative 15i. Less, plus 3i squared. On the bottom, I'm going to get 25 minus 5i plus 5i minus I squared. This is going to become minus 3 because it's positive 3 times negative 1. 20 minus 3 is 17. Negative 4i and negative 15i is negative 19i. These cancel, and this becomes plus 1, get 26. So when I separate this, I get 17 over 26 minus 19 over 26i. I can check both of those. I know 17 and 19 are prime, so that is not going to be able to be reduced. I've got my lesson master here, and 6, 7, and 8 ask me to solve and express an A plus BI form. So for each of these, I'm going to want to use the quadratic formula. So what I'd want to do is I would want to first always say what my A, B, and C values are. Now I will tell you for number 6, this one I probably wouldn't use the quadratic formula. I would probably just subtract 43 from both sides and say z squared equals negative 43. Since there's no middle term, I don't have to use the quadratic formula. And then when I take the square root, remember, since I took the square root, it's plus or minus square root of negative 43. And that negative gets pulled out and becomes an I, and that becomes 43. If you're wondering why that happens, negative 43 is the square root of negative 1 times the square root of 43, which is I square root of 43. So I would do that one just in a real simple way. For this one here, I'm going to look at my A, B, and C values. So A is 1, B is 2, C is 2, and you'd want to go through and use the quadratic formula. Make sure you simplify at the end to the simplest form possible. But I'm going to let you try putting that in the quadratic formula. Remember, quadratic formula is opposite of B plus or minus square root of b squared minus 4ac all over 2a. So you're going to substitute each of those values in to the quadratic formula. For number 8, before you can use quadratic formula, you first have to factor out that x, and then you're left with x squared plus x plus 2 equals 0. So one of my solutions is x equals 0. But then to get my solutions with this, I'm going to have to use quadratic formula. So first give me your A, B, and C values, and then use the quadratic formula, which we have written right here, and you'll be able to find those answers. So you're going to just pull out your A, B, and C values and use quadratic formula for those. And then, notice this says let q equal 6 plus 7i, and let u be the complex conjugate of q, which means u is 6 minus 7i. So then when you do q plus u, you would do 6 plus 7i plus 6 minus 7i, and get your like terms together. We're adding here. I'm not going to continue. I'm going to let you finish the work for that one. Here you're going to do q minus u, so you're going to do 6 plus 7i minus 6 minus 7i. Don't forget to distribute that minus sign to both. And then you'll get your answer. I'm going to let you do that yourself. Q times u, you're going to take 6 plus 7i and multiply by 6 minus 7i. And you're going to use FOIL to find this one. For q divided by u, you're going to have 6 plus 7i divided by 6 minus 7i. But you can't leave it like this. You have to rationalize the denominator. So you have to multiply by the complex conjugate of the denominator, which is 6 plus 7i. The first value stays the same. It's the second one that changes. And you have to multiply by the same thing on the top and bottom. So you're really just multiplying by 1. And then you're going to FOIL the tops and bottoms and simplify, just like we did in all of our examples. In 9F, you're going to have u on top, which is 6 minus 7i, divided by 6 plus 7i. Again, you have to rationalize the denominator, so you're going to multiply by the complex conjugate, which is 6 minus 7i. First term stays the same, the second one changes. And you have to multiply by the same thing on the top and bottom. You're going to need to FOIL and then simplify. You will get different answers. These will not be the same.